This is a video introducing deductive geometry. It's a pretty comprehensive introduction. It covers a lot of basic geometry which you would have learned in year 7 and year 8. If you're familiar with these, you can move forward to the questions at the end of the video. Okay, so let's just cover some key terms before we start. We need to know what a vertex is. We need to know what a line segment is. We need to know the definition of a ray. And let's do a plane, what we mean by a plane. Okay, so a vertex, this is an example of a vertex, A, B, C. So a vertex is a point which joins two or more lines. Okay, so B is the vertex there. A line segment, this is an example of a line segment. We've got A, B. So a line segment is a line which has been cut off at 2 points. A ray, this is an example of a ray, say A. So we define a ray as part of a line we didn't define a line segment, so line segment is bounded by 2 points. And then finally we've got a plane. A plane is a 2-dimensional flat surface which extends infinitely. Okay, so this is an example of, this is the Euclidean plane. And not all surfaces are flat. So we can have, in spherical geometry, a sphere, and so on and so forth. Okay, so let's move on very quickly. So you can pause the video and you can write down these terms: adjacent angles, complementary and supplementary, so on and so forth. Okay, so hopefully you paused the video now and you've drawn and explained all those points. So I'm going to do it very quickly. Let's choose a different color. So we needed to choose adjacent angles. So let's do A, B, C, and D. And this is the common ray. We have a common vertex. And the angles which are adjacent, let's call them, I don't know, alpha and beta. So alpha and beta are adjacent angles. So adjacent angles is just a posh word for next door to each other. Okay, complementary and supplementary angles. So complementary sum to 90. They sum to 90. Supplementary angles sum to 180. Okay, so we're making some progress here. Let's define this as theta. It's just a letter of the Greek alphabet. This is beta and this is alpha. So can you write down the complementary and supplementary angles there for me? Okay, so we've got beta plus alpha is equal to 90, and we've got theta plus beta plus alpha is equal to 180. This is complementary, and this is supplementary. And we've got angles at a point. Okay, so angles at a point. Now let's do alpha, theta, and beta. You should know that alpha plus theta plus beta is 360. We've got vertically opposite angles, and this is alpha, alpha, beta, beta. Vertically opposite angles are equal. Okay, so we're moving on to parallel lines. Okay, so we use these two lines for parallel. Parallel lines do not meet. If we draw on a line extends forever, so we put these arrows on. If we got something like a parallelogram, and we got one set of parallel sides, two sets of parallel sides. So parallel sides do not meet on the Euclidean plane, the flat plane. They do meet on the spherical plane and in non-Euclidean geometry. So railway tracks on a flat surface drawn on a plane on a piece of paper do not meet, but railway lines, if extended, will eventually meet on the spherical plane. Okay, so we're making good progress here. Let's move on to angle sum of a triangle and the exterior angle theorem. Okay, so we should be familiar with angle sum of a triangle. So let's have a go at doing that. Got a triangle. We've got A, B, C. Well, A plus B plus C is equal to 180 degrees. Got the exterior angle theorem. A, B, C, and D. And the exterior angle theorem says that A plus B is equal to D. So I'm going to take a little diversion here. Can you pause the video and see if you can prove the exterior angle theorem? Okay, so you should have done that now. So let's see if we can do a proof. Okay, so let's define C in terms of D. So we know that C is equal to 180 minus D. So we know that A plus B plus 180 minus D is equal to 180 degrees. We can subtract 180 from both sides to leave us A plus B minus D is equal to 0. We can add D to both sides to get A plus B is equal to D. Q, E, D. Some other properties of triangles. Well, you should know that there's 3 types of triangles. There's a scalene, there is isosceles triangle, and there is an equilateral triangle. So let's draw scalene. Scalene has all different sides. A equilateral has 2 of the same sides. Isosceles rather, an equilateral has 3 same sides. Let's look at angles. Well, all these angles are different. these angles are the same, all these angles are the same. Okay, so we've got angle sum of a quadrilateral. So quadrilateral is any 4 points. Let's join these lines. Let's call this A, B, C, D. A plus B plus C plus D is equal to 360. Did I say 180? Angle sum of a quadrilateral is 360. Okay, so I think let's elaborate on the parallel sides and their angles. So there's 3 types of angles we need to know on parallel lines. Let's go over them very quickly. There's alternate, there's corresponding, and there's co-interior. Now, these are lines that extend forever. So alternate angles are these. Alternate angles are equal. Corresponding angles are equal as well. These are corresponding. Triangle, triangle, square, and square. And we also have vertically opposite, which I'll go over shortly. Okay, often when we draw lines, we don't put the arrows at the end. Though technically that infers that it's a line segment. So in examinations, we need to make sure that we put in arrows on both ends of the line. Otherwise, we're saying that the line doesn't extend forever, which it does. So for example, the line y equals 2x plus 1 looks something like that. But what you've drawn there is a line segment. You're saying that it stops there and stops there. It doesn't, it continues. Okay, it's a little bit of a tangent, which is funny because we are doing geometry. So co-interior angles sum to 180. So these are co-interior. So sums to 180, and let's do let's do a big circle on a small circle. Let's do, I don't know, red circle. Okay, so red circle plus is equal to 180. We also have vertically opposite angles, which are these. Vertically opposite angles are equal. Okay, so let's move on. So we've done all these. Now, my favorite properties of quadrilaterals. Okay, so when we're defining properties of shapes, we normally want to know something about their angles and their diagonals. So a diagonal is created by joining 2 opposite vertices. So for example, the diagonal here would stretch from there. It's not a very good line. Let's see if we can get a nice line there. Okay. Okay, so this would be the diagonal here. Not have much success here. That would be the diagonal there. That would be the diagonal there. Okay, it's a bit wonky. but you can use a ruler and a pencil. So pause the video and see if you can write down the properties of a trapezium, parallelogram, and kite. Okay, so hopefully you've done that now. So let's have a look at the properties. So a trapezium, what is a trapezium? Well, a trapezium has one pair of parallel sides. So a trapezium has one pair of parallel sides. That means parallel. We can't say anything about the diagonals. Diagonals don't bisect. There are different types of trapezium, like isosceles trapezium, but we're not going to go into that here. Okay, so we've got a parallelogram, and there's lots we can say about a parallelogram. So let's draw the diagonals in. So we can say that the diagonals in a parallelogram bisect each other. So that distance is equal to that distance. We can say that the angles at the vertices bisect. So let's write down the properties of a parallelogram. Okay, so it has two sets of parallel sides, denoted like this. Okay, it has two sets of equal lengths. From the sides, opposite angles are equal. And the diagonals bisect each other. Okay, so a rhombus. So a rhombus has all the properties of a parallelogram. Now, the rhombus has all sides equal. That's the definition of a rhombus. The diagonals are perpendicular. We need to mention that. That's how they differ. The diagonals of a rhombus are perpendicular. So let's write that down. So all the properties of a parallelogram plus are perpendicular. You should know that perpendicular means right angle, which is 90 degrees. Okay, so we're making good progress here. Okay, so we've done the most difficult ones first. So let's do a rectangle, which you should know. So equal, equal. A rectangle has two pairs of equal sides. The diagonals bisect each other. So bisect means to cut in half. If I was to bisect you, I would cut you in half. That is equal, that is equal, that is equal, that is equal. Okay, so These are not the best drawings. It's very difficult to use this Wacom pen, but you get the general idea. So diagonals bisect, diagonals intersect at 90. No, they don't. The diagonals, what a silly thing to say, the diagonals bisect vertices. Okay, I was thinking of a square. The properties of a square are diagonals bisect again. So let's draw that in. And diagonals bisect angles at vertices. Okay, kite is my favorite quadrilateral. Okay, so kite diagonals are perpendicular. What other nice things can we say about a kite? The shorter diagonal bisects angles at the vertices, so these angles are equal. And do I want to mention anything more? I'm racking my brain about kites. And let's mention this. Two pairs of equal sides. So this is one pair, and this is another pair. Do we need to say anything about anything else about the kite? No. Do I want to go back to the square? Yes, I do. 3, the diagonals intersect at 90 degrees, which is another way of saying diagonals are perpendicular. Okay, so let's move on. So I want you to pause the video and I want you to find the pronumerals. A pronumeral is a letter which represents a number. So let's write that down. So a letter which represents a number. So pause the video and have a go at doing these, please. Okay, so hopefully you've done that now. And I will show you how to set these out correctly. Okay, so under no reason should you be writing x is equal to 50. Okay, it's the correct answer, but we need something more at this level. Even given a reason is still not sufficient, because you need to give a reason and you need to demonstrate a solution and good mathematics. So x plus 40 is equal to 90. Okay, we know this, because right angle given. So then we can say x is equal to 50 degrees. That's the correct way to work out A. So B, we can say y plus 70 degrees is equal to 180. Why? Why is it equal to 180? Because y and 70 are adjacent angles on straight line. Okay, so I've marked papers saying that y and 70 are supplementary. That is still not sufficient because we need to say why they're supplementary. And given a straight line, that is reason enough. Okay, so then we can say y is equal to 110. C, well, now we can say t is 64. And the reason vertically opposite angles. So here we've got u plus 125 plus 112 is equal to 360. So we need to provide a reason for that. Why is this statement true? And this statement is true because the angles are not at a point. So in brackets, we can say angles at a point. And then we can say u is equal to 360 minus 112, subtract 112, subtract 125, so we get 123. Okay, so we're making good progress. Let's have a look at some more problems. Okay, now I think you're going to enjoy these problems. So pause the video, and this is where your maths and geometry interact. You're going to have to use some geometrical reasoning to describe and explain, and then you're going to have to use some maths to solve the equations. Okay, so let's have a go at doing these. What color do I feel like using? Let's use red. Okay, so what shape is K? What is a rhombus? So what are the properties of the rhombus? We're asked to find R. So R is 90 degrees. Now we need to provide a reason, okay? If we are providing a proof, we need to link each line and eventually arrive at an answer. Subsequent videos will show you how to do proofs. In these questions, we need to provide a numerical answer with a reason. So we can say diagonals intersect at 90 in a rhombus. Okay, a better way to write that is diagonals are perpendicular. Both will be marked correct in the exam. Diagonals are perpendicular in rhombus. Okay, so what else have we asked? S is 46. Y, diagonals bisect vertices in a rhombus. Okay, so hopefully you've had a go at doing L. So J is 20 and K is equal to 6. So we need to provide a reason. Before we do that, we need to say what shape this is. Okay, so shape L is another rhombus, but it looks like a kite. A little bit. Okay, so we need to say, so diagonals bisect in a rhombus. And that is sufficient for both. So we've got n. So this is a square. So in a square, diagonals are equal. I'm going to write equal sign. Okay, so all looks fun. This is a square again, so we can write y equals 90. We can write diagonals. A perpendicular in square. Okay, you're going to have to excuse the pen. And we can say z is equal to 4 because diagonals bisect in a square. Okay, the pen is rubbish, but I'm going to do my best. Okay, so let's have a look at some more questions. We're making really good progress. Now, these are a little bit more involved. This question is a little bit more involved. Pause the video and see if you can do these questions. Remember to provide a reason. Okay, so when I get questions like this, hopefully you've done those. I like to extend these. Okay, so let's have a think how I'm going to do this. So we need to write down what shape this is first. And the shape we have here is a parallelogram. We can write straight away that m is equal to 38 degrees. Why? Because diagonals, not diagonals, opposite angles are equal in a parallelogram. We can write that n is equal to 180 degrees minus 38 degrees. And why can we say that? That's what we need to put in brackets. We can say that because they both sit on a straight line. 1, 4, 2 on a straight line. Okay, so we've got B. Let's do B up here. This is a rectangle. So we got B is equal to 90, Y 90 in rectangle. Okay, so we should say internal vertex angles. So C now is going to be 360 minus 133 minus 90, which is 137, because angles at a point. Okay, so we're making really good progress. Nearly forgot about C. So what shape is C? C is a rhombus. Okay, so we can say A is equal to 90 because vertices are perpendicular in a rhombus. We can say that B is equal to 180 minus 69 minus 90, which is 21. And we can say angle SAM triangle 180 degrees. Okay, so this is angle, this is Greek letter SAM, triangle 180 degrees. If you're not comfortable with those terminologies, you can just write angle SAM triangle 180 degrees. Let's do that. Okay, so we can say that B is equal to 21 because vertices bisect angles. Okay, we've got a nice one here, which is D. This is lovely. So I'm just gonna rub this out. Now, what we can use here, if we extend the lines, let's extend it in red. Perhaps you can see what's going on here. Okay, we have got an alternate angle here. So C is equal to D by alternate angles. So we know that C is equal to, we got C no, we didn't. So we'll say B is 21. We've got this is 90. Brain freeze. So we've got A is equal to 90, B is equal to 21, of course. So these two triangles are congruent. Okay, so we can flip these. So this triangle here is equal to this triangle here. They're congruent triangles. So B and C are equal. B and C are equal. So C is going to be equal to 21, and hence D is going to be equal to 21. Okay, so even experienced mathematicians can have moments of madness where their brain freezes. Congruent means mathematically identical. Okay, so these two triangles are congruent, so we can say bicongruent triangles corresponding angles are equal. Okay, so let's have a look at wow. Okay, so pause the video and see if you can have a go at doing these. I'll see if I can do it. Okay, so hopefully you've done that now. You've paused the video. So we've got an equilateral triangle here. So we know that A is 76 degrees, D by triangles, it's not equilateral. Okay, so we see that B is also 76 by vertically opposite angles, and we can say C is also equal to 76 because opposites are equal in parallelogram. Okay, let's do E. So pause the video and see if you can have a go at doing E. Okay, so X is equal to 73 by alternate angles. We can write this for angles. Let's write these in. So that is 73. Now we have some more. Okay, so on parallelogram, this is equal to 73 because angles bisect at vertices in parallelograms. So we can say that Z is equal to 180 minus 73 minus 73 by angle sum of a triangle which is 34 by angle sum triangle. So if Z is 34, so is Y 34 because opposite angles are equal in a parallelogram. Okay, so we've got 34, 34. So if we sum these, we should get 180. Let's see. 73 plus 73 plus 36 is 182. Where have we gone wrong here? 34. Yeah, good. Okay, brilliant. So F is pretty straightforward. I'm not gonna do F. I'll let you work that out. That's 90 degrees, and we know that's a straight line, so I'm sure you can do F. Nice and easy. Oh wow, we're coming to the end of the video, so pause this and see if you can have a go at doing these questions. Okay, we've covered a huge amount. Okay, so for 14, we just use the fact that angles on a straight line equal 180 degrees. Angle sum of a triangle, we should get x is equal to 35 degrees. I fill in some for you. So we know this is 60 degrees. We know that this, so we can work out that's 120 and so on and so forth. So 15 I'm going to do. So what shape is that? We are given it's a rhombus. So angles bisect in a rhombus. They also create equilateral triangles here. So let's finish off. So we could use equilateral triangles there. So this is 72. So we know that 72 degrees plus 72 degrees plus angle B is equal to 180. So we know that angle B is equal to 180 minus 72 minus 72, which is 36. And we're asked to find x. Well, x is going to be the same as 36 divided by 2, which is 18 degrees. Now, we do need to provide reasons, so let's do that then, okay? Isosceles, triangle, and I'm going to say angle sum triangle 180 degrees. Here, we are going to say angles are let's write vertices, diagonals bisect vertices. At vertices. And then we can finish off by saying that opposite angles are equal in rhombus, hence 36 divided by 2 is equal to 18. Okay, brilliant. So we covered a lot in this video. And if you're able to do all the problems, including 14 and 15, you were doing very well.